Good afternoon, students. Today we are going to see the next chapter. That is nothing but chapter number 2. That is your mechanical properties of the fluid. Right? So now, what this fluid is, that is the first thing. So we are going to see the mechanical properties of this fluid. Now, up till now, what we have seen that your matter has different states. You have seen that matter has a state. One is solid, second is liquid, third is gas, fourth one is plasma. Now, what this plasma consists of? So, this plasma will consist of the gas gas of ions. It consists of free electrons as well as it consists of neutral atoms. So, plasma consists of gas ions, electrons, and the neutral atoms. And there is one more fixed state is there, which is to be called as a Einstein-Boltzmann state. Or Einstein-Boltzmann condensation. So this is nothing but the fixed state of the matter. Clear? In that, now we are knowing that this solid has a definite shape, while liquid and gases, these two has no shape, no definite shape, but it has a fixed volume. And this solid has a definite shape. It has a definite volume. It also has a definite volume. But liquid and gas doesn't have a shape. It has a fixed volume, and this liquid and gas will take the shape of the container. That is, whenever we are going to place your liquid in the cubical flask, so it will take the shape of that cubical flask. If I am going to enclose a gas in a cubical container, so gas will take the shape as a cubical container. So wherever you are going to place it, in which container you are going to place it, so liquid and gas will take the shape of that particular container. Is it right? Now, what this fluid is? This liquid and gases, they are to be called as a fluid. Why? That is, liquid is the substance which can flow. The substance which can able to flow, that substance is to be called as a fluid. So out of this matter condition, your liquid and gas as well as plasma, all three are under the class which is nothing but the fluid. That is, liquid can flow, gas can flow, plasma can flow. So all these three states of the matter are to be called as a fluid. Clear? And due to this, as this liquid, gas and plasma, they are the fluid that doesn't have a definite shape. Means they can possess only water. Right? But solid cannot flow. So as solid cannot flow, that's why it has a definite shape. While liquid, gas and plasma can flow, therefore it doesn't have any shape. It has only water. Now as solid has a shape, therefore this solid must possess a shearing stress, or I can say that solid has a modulus of rigidity. Solid has a property of rigidity. Why? Because it has a definite shape. But liquid and gas doesn't have a shape. So it doesn't have a shape means it will not possess. There is no shearing stress. As it has a no shearing stress means they have no rigidity property. So ideally I can say that the modulus of rigidity of liquid, gas and fluid is 0. Is it right? Because it doesn't have a shape. So as it doesn't have a shape, it doesn't possess the property of shearing stress and therefore it doesn't have a modulus of rigidity. Right? So here is your important MCQ. That is solid, liquid and plasma have no modulus of rigidity. Or I can say that ideally fluid has no rigidity modulus. Clear? Then what fluid has, which property that fluid can possess? So now I can discuss about the properties of the ideal fluid. Ideal fluid means what? Practically fluid has another property. Ideal fluid has, so ideal fluid has certain properties. What that ideal fluid has a certain property. So in that, the first property of ideal fluid is it is incompressible. It is incompressible means what? The density will remain constant. Incompressible means what? It is not able to compress. अगर compress नहीं हो रहा है तो density change नहीं हो रहा. Density change नहीं हो रहा means what? Incompressible means what? Density will remain constant. This is the first property of ideal fluid. Then its second property. The second property is its flow is irrotational. Its flow is irrotational means what? Its flow is constant and smooth. Smoothly, I can say that its flow is smooth. Smoothly the fluid can flow. I can give the example. If I take honey and if I pour the honey on a table, so see that the layer of honey will get uniformly distributed in a short region of area. Is it right? Means what? The flow is smooth, flow is constant. So what I can say that honey has a flow which is irrotational. Is it right? But if I am considering water, they will pour a water. So water immediately gets spread out everywhere. So that flow I will not say as a smooth flow. Or that flow I am not going to say as a constant. Clear? Then next, its third property. Its third property is nothing but it is non-viscous. It is non-viscous. Non-viscous means what? Whenever I am saying a fluid is flowing, means the fluid will be flowing in the form of layer. So upper layer is not exerting any force on the lower layer. Or second layer will not exert force on the third layer. So what I can say that there is no viscous force. So whenever the consecutive two layers are not going to exert any force, then that is to be called as a non-viscous force. And the flow is to be called, or the fluid is to be called as a fuzzing the property, which is to be called as a non-viscous property. Then its fourth property of your ideal fluid is nothing but its flow is constant or its flow is steady. Flow is steady. Flow is steady means, just now I have given the example, that is whenever I am going to pour a honey, so that honey will be moving over the particular region, particular surface, that with a constant velocity. So at that time I can say that the flow of honey is steady. So these are called as properties of ideal fluid. So first property of ideal fluid is it is incompressible. Incompressible means density will remain constant. Second is the flow of fluid is irrotational. Means the flow is smooth. Flow is constant. Then the fluid has a property of non-viscous. Means The fluid will be flowing in the form of layers. No any layer will be exerting force on the constituent layer. Means there is no viscous force. The fourth property is the flow is steady. The flow is steady means what? The fluid will be moving with a constant velocity. Right? So these are the four properties of fluid. So that property you have to remember for MCQ question or for very short answer. Clear? Now we are going to consider the basic difference between solid, liquid and gas. Now what that basic difference is, that is the property of shearing modulus. That is, you have seen in 11th standard that if I am considering a cubical structure, in that the lower surface of cubical surface, Q, I have met it fixed. And if I am going to apply a force on the upper layer of this solid, so this upper layer force is a tangential force. So when I am going to apply a tangential force on the upper layer, so this upper layer I can say as a AB upper layer will get displaced. And I am getting the parallelepiped shape as a dash, B dash, C and means your upper surface will get shifted to certain angle theta with respect to fixed surface. So this force I am going to call as a shearing stress. So due to that shearing stress, the tangential force applied on the upper surface area, which is called as a shearing stress. So due to that shearing stress, the cubical shape it changed into parallelepiped. Means I can say that solid possesses the modulus of rigidity. Right? So this is nothing but the property of the solid. Or I can say that that solid has also the property which is nothing but on a solid. Suppose this is the solid surface, or that solid if I am going to apply the force from upper side and lower side. Is it right? So what happens? It will get compressed. Is it right? So what I'm going to say that this type of strain is to be called as, this type of stress is to be called as a compressive stress. Right? Instead of that, if I'm going to apply a force in the outward direction, so this I'm going to call it as a compressive stress. Because I'm applying a compressive force, so its volume will goes on changing. Volume will get compressed. Here, if I apply a force in the outward direction, so what happens? Your solid will get extended. So that I am going to call it as a tensile stress. Means here is the change in volume, and here is the change in shape, here is the change in volume, and here is the change in length. Means what we can say that solid possesses property of change in shape, property of change in volume, and property of change in length. And that gives us your free elastic constant. That is solid possesses modulus of rigidity, then bulk modulus, as well as modulus of Young's modulus. Is it right? While liquid, in liquid, what is the thing? In liquid possesses only volume. So as it possesses only volume, so due to application of stress, the volume will get compressed or volume will get released. So only there is a change in volume. So as there is only change in volume, means what I can say that liquid and gases possess only bulk modulus. Its modulus of rigidity and its Young's modulus is 0. So that is the basic difference between solid and liquid. And due to this property, as solid has all three modulus, it has a definite shape. While liquid has only the property of bulk modulus. Therefore, liquid possesses only volume. It doesn't have a definite shape. Right? Now, liquid is nothing but fluid because it can flow. So now we can say that your liquid and gases, as they can flow, so liquid and gas are to be called as your fluid. So I can say that your liquid and gas both are to be referred as a fluid. Why? Because they can flow. So I can say that now the properties of fluid, which are nothing but the properties of liquid and gas. So practical fluid. So what is the first property of the practical fluid? That first property of the practical fluid, that is that fluid does not oppose deformation. Means whenever compression is there, the liquid will get compressed. Liquid will get compressed means what? There is a change in volume. Change in volume means what? It will not oppose deformation. Deformation is which deformation? Change in volume. That is the basic property of the fluid. Second property is it has the ability to flow. So it has the ability to flow. So liquid and gas can easily flow. And the third property is as it has the ability to flow, so it will take the shape of container. It doesn't have its own shape, but wherever it is going to be placed, it will take the shape of the container. So these are the practical properties of the practical fluid. Is it right? Now as it is compressible, here it undergoes the deformation. Means what? There is a change in density. It has the ability to flow. Means might be velocity will not remain constant and it will take the shape of the container. Clear? So these are the basic properties of the fluid. Now, at the same time, these fluids can possess the properties which is nothing but the fluid exert a pressure. The fluid also has a property of surface tension. And the fluid has a property of viscosity. And in this chapter, we are going to concentrate on the properties, that is surface tension and the viscosity. That is how that fluid can possess the property as a surface tension as well as how it can possess the viscosity. Clear? So now I will switch over to the property, and that property is to be called as a surface tension. So the mechanical properties of the fluids are three. Which are the three mechanical properties? That is, every fluid has a pressure, every fluid has a property of surface tension, and as well as it has a property of viscosity. In that, first now we are going to concentrate on the property which is to be called as the surface tension. Now, what are the practical example of the surface tension? The very famous practical example of the surface tension is, that is, if you observe any water reservoir, so over that water reservoir some insect can float, right? So that is one of the examples of the surface tension. If you are taking a needle, and if that needle is coated with grease, so that needle can float over the liquid. That is also the example of the surface tension, right? So these different examples of the surface tension that you have to observe under this topic, which is nothing but called as your surface tension. So your greased needle can float on the surface, is it right? Or if I put a water drop, if I drop a liquid drop, so that liquid drop will take a spherical shape. It will not immediately flows out. जैसे मैंने ड्रॉपर में कुछ लिक्विड लिया है और ड्रॉपर से ड्रॉप बाय ड्रॉप इफ आई एम गोइंग टू पोर दैट लिक्विड ओवर द सरफेस, तो जैसे ड्रॉपर से वो ड्रॉपलेट नीचे गिरेगा, so that droplet will take the shape of spherical shape. Why? Due to the property of surface. So surface tension is the property of liquid by which it can minimize its own surface area. That property is to be called as your surface tension. Now, before starting the concept of surface tension, we have to clear out the certain terms which will oftenly comes under the topic as a surface tension. In that, the first term which will come under the surface tension, which is nothing but the intermolecular forces. So intermolecular forces means we are knowing that in case of liquid, intermolecular forces are weak. That's why liquid can flow. Right? Now these intermolecular forces are of two types. One is to be called as a cohesive force and another is to be called as a adhesive force. Now what is cohesive force? Cohesive force is a force which will be exerting between two molecules of the same substance. What is meaning of this? Means the force between two water molecules is nothing but the cohesive force. Or I can say that the force between two molecules of the honey is nothing but the cohesive force. Fine? Why? This adhesive force is nothing but the force between two molecules of different substance. Different substance. Means, here's the example. Here is the board. Board has its molecule. Over that board, I am going to write by the chalk. Is it right? Means there is a force of attraction between the chalk particle and board particle. That force I am going to call it as a adhesive. Clear? Why? This chalk is made up of thousands of minute particles. So these thousands of minute particles are bounded together to form a chalk due to a force. That force is to be called as a force. Right? Now, this cohesive force is a stronger force, while this adhesive force is less strong. So, as compared to cohesive force, adhesive force is a less. Is it right? So, this is the basic difference between cohesive force and adhesive force. So, this is the first term which we have to concentrate under this surface tension. Got it? Then, the second term which will come under this surface tension, that second term is nothing but the intermolecular range. Second is nothing but the intermolecular range. Now, what is intermolecular range? Just now we have seen intermolecular forces. Which two intermolecular forces? Cohesive force and adhesive force. Cohesive force is also a force of attraction. Adhesive force is also a force of attraction. Then what is the difference? Cohesive force is the force between two same molecules of the substance. And adhesive force is the force of attraction between two molecules of different substance. Is it right? Now, what is intermolecular range? The minimum distance up till which your force of attraction will remain effective. That minimum distance is to be called as your intermolecular range. Means if I'm going to consider two water molecules, so these two water molecules are attached to each other. So this is nothing but the distance, effective distance between that two molecules where your force of attraction is effective. If I'm going to place one molecule here, one molecule here, so the distance will go on increasing. So all this distance, there is no force of attraction. So intermolecular range is what? It is the minimum distance between the two molecules so that your force of attraction will remain effective. That is to be called as your intermolecular range. And this value of intermolecular range is effective up till distance. The intermolecular forces are effective in solid and liquid up till 10 raised to minus 10 meter. And therefore, these intermolecular forces are to be called as a short range force. So here is your MCQ. The value of intermolecular range in case of solid and liquid is 10 raised to minus 9, right? Or it is also to be called as, it is equivalent to nanometer, 1 nanometer. Got it? So this is nothing but your intermolecular range. Then the third term is nothing but, which is to be called as a sphere of influence. Sphere of influence. Sphere of influence is what? If I will take the radius, which is equivalent to intermolecular range. If I take a radius of the sphere, which is nothing but equivalent to intermolecular range. And if I draw a sphere around that molecule, here is your molecule. And around that molecule, if I draw an imaginary sphere whose radius is equivalent to your intermolecular range, then this sphere is to be called as a sphere of influence. What is the meaning that? That is under this sphere of influence, if any another molecule will come from any side, then that molecule will be within the range. So that molecule will get attracted towards the center. So within the sphere of influence, if any molecule will come, then that molecule will get attracted towards the center. So that is nothing but as your sphere of influence. Right? After the sphere of influence, now I can say that the next term, which is nothing but here I can say the fourth term, which is to be called as the surface film. Now what is surface film? Suppose I have taken a container. Inside the container, it is filled with liquid. So that the level of surface is x1. Is it right? And now, if I am going to draw here the sphere of influence, here I will show the molecules like this. So this is nothing but your sphere of influence I have drawn for the molecules. So this film, I am going to call it as a surface film. So surface film is the layer of liquid whose thickness is, the thickness of this surface film is equivalent to that of your intermolecular range. So if your thickness of surface film is equivalent to intermolecular range, then it is to be called as your surface film. Right? And the fifth term is nothing but the free surface. So here, this xy, I am going to call it as free surface. And this x dash, y dash, I am going to call it as a surface. Right? So free surface means what? It is the interface between the air molecule and water molecule. Above xy, there is a presence of air molecule. Below xy, there is a presence of water molecule. So interface between two molecules, that layer is to be called as a free surface. So these are the important terms which you have to consider under this concept as the surface tension. So first term I have explained intermolecular forces. That intermolecular forces are of two types. One is cohesive, second is adhesive. Second term I have explained intermolecular range, whose value is 10 raised to minus 9 meter. Third term I have explained, which is the sphere of influence. So sphere of influence is a sphere whose radius is equivalent to intermolecular range and center is nothing but itself a molecule. Right? Then we have seen surface film. The thickness of film, which is equivalent to the intermolecular range. That film of liquid is to be called as a surface. And the free surface. Free surface is nothing but the interface between the two different molecules. Like here, above xy, air molecule, below xy, water molecule. So xy will act as the interface between air molecule and water molecule, which is to be called as your free surface. Got it? So these are the important terms which we are going to come across with this term, which is nothing but as your surface tension. Clear? And now we are going to concentrate on the actual term, which is to be called as your surface tension. So now, here, if I am going to enclose a liquid in a cylindrical container, so here I can say that this is the upper face and this is the base. And this surface I am going to call it as X, Y, Z. This circular surface is nothing but the free surface. For this free surface, this is nothing but the surface. And over this surface, a tangential force is going to be act along the length of the surface. So this tangential force per unit, the tangential force acting on a perpendicular length is to be called as your surface tension. So surface tension is nothing but the tangential force acting per unit length is to be called as your surface tension. And as this tangential force is acting over the surface, it will try to minimize the shape of that liquid surface. So due to that tangential force, the shape of the liquid surface tries to minimize. And it will create a tension over the surface. And that's why that term is to be called as your surface tension. See here, this tangential line, across that tangential line, your tangential force is acting. It wants to tear the surface. So it wants to create a certain tension over the surface. That tension is to be called as the surface tension. So how we are going to define the surface tension? Surface tension is defined as tangential force acting per unit length of that particular surface. And therefore, what I can say that the unit of this surface tension is nothing but Newton meter. And now its dimension. Dimension I will say that force dimension m raised to 1, L raised to 1, T raised to minus 2 divided by length. Length dimension is L raised to 1. So this L raised to 1, L raised to 1 dimension will get cancelled. And what I am getting the dimensions of your surface tension. That dimensions of surface tension which I am getting, which is equivalent to m raised to 1, L raised to 0 and T raised to minus 2. These are nothing but your dimensions of your surface tension. Clear? Any doubt? So your tangential surface tension is defined as a tangential force acting per unit length on the both the side of imaginary line drawn over the liquid surface is to be called as your surface tension. And its formula is surface tension T is equal to F upon L. Unit is Newton per meter and its dimension is nothing but m raised to 1, L raised to 0 and T raised to minus 2. Got it? Any doubt here? Clear? So now today I am going to stop my lecture here. Next time we are going to consider the new terms under this surface tension. Any doubt? Everything is clear here? Now afterward, we are going to consider here one more thing I want to explain here as a surface tension on the basis of molecular theory. So that concept we can see in the next. Clear? So here I am going to stop my lecture now. Bye.